Hey guys, we're going to be doing math lesson 118, and what you guys are going to need is, of course, a ruler, a pencil, and your math lesson 118. And we're going to be talking about perpendicular lines, and I have a little tiny clip of a video that I want you to look at so you get an idea of what perpendicular lines are and review what parallel lines are. Okay, so go ahead and pause this, grab your stuff, and then push play and watch the video.
Now, here's two lines, one next to the other. They're called parallel lines because they never touch. The lines in this notebook, or the steps of this ladder, are parallel. We can turn a parallel line to make it vertical. When parallel lines crisscross, they change to perpendicular lines. Perpendicular lines look like this crossroads, or the frame of this window. What a lovely day.
Okay, so we have an idea of what perpendicular lines look like, but I want you to grab this paper right here and we're going to do some work on this to practice perpendicular lines. Okay, we have lesson 118 here. You have your problem of the day on top. Go ahead and do that if you have questions on that. You guys can also send me pictures of your problems of the day and I'll help you with that. And we are reviewing our times twos again, so go ahead and do your times twos on both sides. And then we are going to work on perpendicular line segments today. Okay, we're going to do some examples of perpendicular line segments. Now, perpendicular line segments are two lines that meet at a 90-degree angle. Now, that means just like a right angle. Do you remember we did a triangle that looked like this? Okay, and we had the line connecting across. And remember I said a right angle is one that a piece of paper can fit right into the corner. See how that fits right there? This is what a right angle looks like. And actually, these two lines, if I connected this even before, this is a parallel, not a parallel line, a perpendicular line because they are crossing at a 90-degree angle. Perpendicular lines come in many different ways. They look different. Sometimes they can be a capital T, looks like a capital T, okay? Or they can be just an L, okay? Or they can actually be an X. Okay, if I have an X here and I turn it this way, guess what? It's a T again. And we can also check by putting our corners in there, the two lines like this. Oh, you can't see. There we go. So here are some examples of perpendicular line segments. They definitely hit each other, unlike parallel line segments, and they meet at 90 degrees, which is a right angle, which means you can fit a piece of paper in any one of these corners and it fits. Okay, so when we look at our paper today, you're going to get a chance to circle perpendicular line segments. Okay, perpendicular. And remember, parallel is like this, and that's not what we're talking about today. We are talking about perpendicular. So if you want, you can try your own perpendicular line here. If you want, you can use some of these and try your own perpendicular line. Okay? If you have any questions, let me know. Okay, we're going to start on our lesson 118. So, of course, we are going to measure. It says 7 centimeters. So we are going to measure 7 centimeters. Make sure you put your name. Let's measure. This one is 5 centimeters. Now, let's read our word problem. It says, pencils are sold in packages of 3. So 3 in one package. Miss Conlon bought 7 packages of pencils. Draw a picture to show the packages of pencils. So let's read it again, and now we're going to underline what we need to draw. So pencils are sold in packages of 3. So that means groups of 3. Miss Conlon bought 7 packages. Okay, so there's 7 groups. So let's draw a picture. So we know there are 7 groups. 1, 2, 3, 4, 5, 6, 7. And in each group, there are 3 pencils. I'll let you just draw lines for this one. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, what type of story problem is this? This is going to be a multiplication problem. So we are going to have, what is this called? Not some more, not some went away, but this is called equal groups. Okay, because they're all the same amount in every one. Okay, so now we need to come up with a number sentence. We know equal groups is multiplication. So how many groups are there? There are 7 groups. How many pencils are in each group? Times 3. 7 times 3. We can either count by 3s, 3, 6, 9, 12, 15, 18, 21. Or we can know 7 times 3 is 21. We need to start learning our multiplication. All right, so we need a label, 21. Draw a picture to show the packages of pencils. So 21 pencils. Answer is 21 pencils. Okay. All right. Now, if we just learned parallel lines go like this, okay? Perpendicular is what we need to find. Remember, perpendicular is like this, or it can be anytime where there is a right angle. Okay, so let's look. This is parallel, so we don't want this, right? We want perpendicular. A paper can fit in here, so we're going to circle that one. This one's a little tricky, but if you turn your paper like this, it's going to be a T. Okay, so a paper could fit in the corner here. Here, now there's no L's or T's in this, so we're not going to do anything to that. And that one is a perfect T. Okay, so there are 3 perpendicular line segments in there. All right, let's look at number 3. It says, how many small squares are in the rectangle? We're going to do area. Now, remember when we did the squares that we did up and down? So what we're going to do is we're going to count how many squares. 1, 2. So there are 2 squares here. And then we're going to count the bottom. How many are across the bottom? 1, 2, 3, 4. 4. Okay, and so we're going to turn this into a multiplication problem. So 2 times 4 is what? 8 squares. And that saves so much time instead of going 1, 2, 3, 4, 5, 6, 7, 8. Okay, color 1 square. We're going to color this one. You just color it with your pencil. What fraction of the part is colored? So fractional part, that means that they want a fraction. So how many squares are colored? There are 1 square is colored out of how many? How many total squares do we have? If you look back here, we have 8. So 1/8 of that square is colored. All right, we're going to round each number to the nearest 10. Remember, our motto is over 4, let it soar to the next number. So is 8 over 4? Yes, it is. So this becomes 80. Over 4? No. So that goes down to 10. Over 4? Yes. So that goes up to 30. Okay. So before we left school, we went over our geometric solids. And they were talking about points. Okay, which is the same word as vertex. So which one of these has at least 1 point to it? Now, a cube. Does a cube have a point, a corner to it? Yes, it does. Now, a sphere. A sphere is a ball. So does the ball have a corner? No, it doesn't. A cone. It has one corner down at the very end. Cylinder, does it have a corner? It's like a can of soup. Are there any corners in that? No. Then a pyramid, yes, there is a point at the pyramid. There's actually a few different points on a pyramid. Sorry guys, I left my shapes at school. All right, let's do our subtraction. We can't take 8 away from 2, so we need to borrow. This becomes 5. We're going to add this 10 to here, so that becomes 12. Okay, 12 minus 8 is 4. 5 minus 3 is 2. And if you guys don't show your work on this and you're just copying the answer, I'm going to send your paper back to you guys and you're going to have to redo it. So make sure I see that you are doing your work. Here, 7 plus 8 is 15, plus 5 is 20. So we're going to put the 2 on top of the tens column and the 0 down there. 6 plus 2 is 8, plus 3 is 11, plus 2 is 13. Okay, then right here, this is adding again. 8, 9, 10, 11. 9 plus 1 is 10, plus 7 is 17. Decimal. 3 plus 2 plus 1 is 6. And we also need to bring down the dollar sign. 8 times 10 is 80. 3 times 100 is 300. Okay, if you guys have any questions on this, let me know. So go ahead and work on the back side of it, similar to how we did here. If you have any questions, refer back to here, or you guys can text me. Okay?